So for 16.1, you're going to be studying vector fields. And the best way to do that, into kind of visualizing these vector fields, in which the vector field on R2 here is a function of f that assigns each point x, y in R2 a two-dimensional vector, right? So this particular program here is online, and you can see the URL here. You can Google this with, and you should be able to get to this equation explorer. So I went ahead and I just put xi plus yj in here. So basically the scalar functions are your p is equal to x, and your q is equal to y. Right. So from there, you can see right here the way the scale is. We can't really tell how long these arrows are, so I'm going to narrow down the scale just a little bit more here. Okay, so now you can see how as we move away from the origin, those vectors start to elongate away from the origin. They all point away. So as y and x increase, the vector itself, right, the magnitude of the vector itself gets larger. So say we have x squared, which now we gotta make this scale a little bit different here. All right. So we're looking at the vector field of x squared I plus yj, and you see that the vectors are all pointing towards the positive x, right? Because your I value, your scalar function in front of I is going to always have a positive value in this case, right? And it increases as you get further away from that origin. In zero at the origin, right? You just have kind of the arrows pointing up, right? Because your scalar function p in front of I there is going to be 0. Now another nice simulation here is, so this is R3, and I took actually from page 1071, figure 10, I just put in the vector field. Let's put the vector field, let's change this. So the vector field y, I, z, j, and x, k, so that vector field, you see kind of this rotational field for that. And then so, for example, if we do -2 here, and that would be your figure 11. So we can increase and decrease the number of particles and field strength. So it's kind of nice to play around instead of having to draw it by hand. And then you could also do figure 12 on page 1071 as well, and kind of view that. And you can manipulate how this looks as well. So it's kind of neat to see this. That's on falstad.com/vector3d. So you can go ahead and do that. So I encourage you to go through these instead of having to draw them by hand every time to kind of see how it is. Definitely you wanted some practice drawing it by hand, but this gives you a better overview of what it looks like all together. All right, thank you.